Hello to viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about Skyroot Vikram 1. So let's dive deep into it. So Skyroot is a Indian private aerospace manufacturing company. Basically, they're making these puppies and they're gonna provide commercial launch service. Now, this company started in June 2018. Now, like, wait a minute, why so late? Why did not we had companies as early as like 2008? Well, a problem is Indian government. Like even in 2018, they were taking a bit of a risk. Even though government said that we are working on it, the paperwork was not there. Like you have to understand that America got a kick in the ass after space shuttle disasters. So they had to turbocharge that. Commercial company will not just, okay, NASA goes to this commercial company makes and launch things based on NASA's specification. That changed to NASA wants this thing, make however you will. Like, I want this, figure it out. So that change, and the fact that a private company will be responsible for launching it, not just like, okay, everything is under NASA. No, NASA is just a, what you call almost a manager, observer, administrator kind of deal, rather than like, okay, I'm gonna design everything and you're just gonna manufacture it. No. So basically, going from a component supplier to a service supplier provider. So that was a very big risk. That's why there are not that many companies in India. Even China figured out kind of early that they need to switch to pivot, and the paperwork was sorted very early on. Now, as of now, when I'm making this video, my best search shows up upwards of 1,000+ people. That means this is a significant company. This is not a chump change. Let's just put it that way. And Pawan Kumarji, this individual, is the CEO of the system. He used to be an ISRO scientist, and they started with early seed. Be mindful, in as early as 2018, they always had that issue. It's like any company who's putting seed, they are like, maybe government may not go through the paperwork, or maybe worst case scenario, takes so long that company won't be viable by that time. So it was a risk. But they did manage to acquire $700,000 plus investment, as in like $750K. And then they started working. Very recently, as in 2025 and 2026 kind of era, government fixed the final loophole, and now they even get international funding. At that point in time, unicorn leap that happened. In May 2026, they got $60 million Series C investment. Yeah, at that point in time, now they are big puppies. Like pocket-wise, they're big puppies. And their valuation is 1.1 billion. Although, to be fair, I do not understand how this valuation math works, but they have a big factory, they have a good ethos, and the fact that they launched something successfully supports it. So what about their technology? The core technology is they want to be on-demand cab service. Basically, what Rocket Lab does with a Department of Defense kind of deal. Basically, Space Force has a requirement where it's like, I phone you, you have to launch as quickly as possible. So the previous record was like 72 hours. Current record is give or take 48 hours. They want to do something similar. Now, there are fundamental stage you have to do if you're talking about liquid rockets. But when you're talking about solid, the only stage that you have to deal with is payload mounting. Other than that, there is nothing more, because again, solid boosters, they are designed from ICBMs. ICBMs are, you put it, you forget it for 20 years, and then somebody goes boom, 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 you press a button, kaboom them. So they do not need to worry too much about it. That's why they are focusing on solid. And India does have a good experience with solid systems. ISRO rockets are also very large segment of them are solid only. So that's what the whole essence is, meaning you pick up the phone, you call us, and we're gonna get your payload to orbit as quickly as possible. And fundamentally, they can make it quicker than any other company that has to deal with a liquid system. So all carbon composite, this is where mathematics is against them. If you want to make a smaller rocket, physics fights you. If you make a bigger shell, let's say a tube, the bigger the diameter, the less surface area you have per volume. Benefit of that is, even though you have to make the wall a bit thicker, you actually carry more propellant, be it solid, be it liquid. You just get surface area to volume ratio better. That was the original design with Starship. Basically, at that time, they used to call it interplanetary transport system. That was 12-meter diameter with carbon fiber. When they shrunk it, that's why they are still not reached orbit, even their 13th flight. By the time you're watching this, 13th flight should have happened successfully, hopefully. It's just that when you shrink it, the diameter, mathematics goes against you. You have to use lighter material, otherwise rocket will barely be viable, or you have to make it huge to carry a very small payload. So they went from basically carbon fiber to steel. They can't do that. So they went from carbon, basically lithium aluminum alloy to fiber composites, carbon fiber composites. So benefit of that is they are saving weight on the structure by 40%. That's huge saving. That's like again, that itself is not a big deal if you're talking about GG rockets, like huge rockets. It does not matter that much. But when you're talking solid boosters and a small rocket, that's like shut up, take money. Shut up, take money. It has to be done. It's no longer optional. It has to be done. Otherwise, the rocket payload will go too low. Now, they have you have to solid boosters, good, fast, powerful, but it's not precise. It's not finessing. It's like it's just like whew. So you need something that finesses it, like controls it, guides it. So that's the job of fourth stage, to do the final orbit trimming, meaning it will add the final delta V. It's like, okay, it's almost like how space shuttle, once the solid booster departed, once the tank was departed, they had two tiny engines, orbital maneuvering engines. Those puppies are the fourth stage in this. So you make your solid boosters in your factories and you transport it. Be mindful, these things are risky. When you're talking about factory side of things, liquid rockets are great for factory. Why? You can keep producing it. You can have that factory next to a school, nobody cares. Because again, fundamentally, it's just a metal tube. Even engine, fancy metal tubes. But when you're talking about solid booster, it's a boom device. It makes dynamite looks like a firecracker. So it is a loaded system, completely system. And in governmental system, based on which country you're looking at, in India, these are classified as class 1.1 or class 1.3 explosives, aka mass explosion hazard. Meaning if this goes boom, it's not gonna cause issue or fire or noise. No. It will delete things. So whenever you are going to solid, you do save money, great, but you save a lot of money in the infrastructures. You can see there is only one umbilical. Why they have the umbilical? That is for air conditioning of the payload. You want to cool the payload as much as possible, and you want to make sure it's dry AF, like very dry, like almost 0% humidity, because if there is a moisture in there, yeah, that will, the moment it goes into space, it will crystallize. It will not boil off, it will become crystals, ice crystals. Sublimation will cause that have to happen, and voila, your equipment is ruined. So dry, cold air, that has to be fed, but that's much simpler compared to anything else. So you have to, you have the benefit that it's a stick. You put the stick, you put the payload, launch. That's the good part. Bad part, it is mass explosion, meaning not only your factory has to be vetted, analyzed properly, and the transport route also cannot go through any civilian part. It has to be like, hey, you are launching a big boom device. How about don't send it through a densely populated area? You can send Falcon 9 through it, nobody cares. Heck, you can send Starship, nobody cares. Those rockets only become dangerous once you have what we call flight termination system. Those are small explosives. Once you have that flight termination system, yes, at that point it's dangerous. Once you have propellant loaded, yeah, it's a miniature nuke. But until that, it's safe. This is never safe. The moment you start to build your fuel grain, it is armed, it is kaboom dangerous. So you save money on the infrastructure of the launch pad, you burn that money into your basically storage and handling and all that. And yes, you can produce it, a lot of it. That's the whole point. It's a missile. And as long as you can maintain temperature, humidity, and ESD safe environment, you should be able to stack a lot of them. Basically, oh, I have 15, 16 ready to go. That should be doable. And because it requires no preparation on the launch pad, they can pull it off. They on paper can even do like 2-3 hours. As long as it takes to integrate the payload, they should be able to do that. That's their approach. That's why they're going with solid. Now, this rocket does suffer when you are going through solid. It has a lot of pros, but also cons. Physics. So solid booster is cheaper, great. Storable, ultra great, but you have to pay in bunker storage, meaning you can't just like, oh, I have a factory and I'm storing like 5 or 6 of that. Yeah, you are looking into Beirut kaboom event. You do not want that. So generally there is a very strict governmental regulations, almost like ordnance storage protocols, how the heck you store it, how, and they have to be far apart that one kaboom event should not kaboom all of them. And again, the structure where you are holding them should be strong enough to tank it. So that is there. And again, your employees will also get hazard pay. It's almost like railway employees get a lot of money, and the employees that have to work on railway tracks itself, because that's a hazardous environment, they get hazard pay. So same thing will happen with people working with this. Again, government, rules, regulation, lawyers, is their department. But that's on the money side. The problematic side is low specific impulse, ISP. Yeah, that is a physics limiter. You can't bypass that. meaning your payload would be much lighter. So this rocket is huge compared to an Electron rocket, but Electron rocket can get almost majority of this payload capacity in 2 stages. This puppy has 4 stages and it's huge. So in simplest term, think in this way: this is a Electron rocket Pro Max, 350 kilograms to low Earth orbit. Now the 4th stage is the final trimming event, because again, while solid booster, super powerful, robust and all that, it's sloppy. It's not gonna get you where you actually need to go. So that puppy's job is, I got this, fine tune it. And because it's a liquid powered, it has the ability to restart, and restarting allows them to solve one of the annoying problem. It's like they can use this itself as a truck, as in launch it into orbit, and it will make sure that one passenger, one payload goes into one orbit, shut down the engine, change your apogee and all that, launch the other payload in other orbit. So one launch can literally send basically different payloads in different orbit. Of course, it will be limited. It won't be like, okay, 20 orbits and 20 payloads. That's not going to happen. But you should be able to get 3 or 4 without depleting the fuel there. So that's the core essence. And that power plant is running on N2O4 as an oxidizer and monomethyl hydrazine as a fuel, so to say. It does have cold gas thruster for fine tuning and de-spinning and all that. So understand that philosophy is very clear. You want to use solid booster, you have to deal with low ISP. How can you compensate for low ISP? Have stage. Basically, this is literally in a scenario where it has to have all 4, not like Rocket Lab where it's like they have a choice whether they want to add kick stage or not. It has to have all 4s. So there is a penalty of having low ISP. But again, they have compensated, and their aim is to basically make it a simple thing. You have a payload, I'm going to stack the payload here, the end. Done. I don't want to think anything more than that. So if they can solve all other hurdles of the launch industry, they should be able to make this profitable. And again, they will replace the upper stage. The conversation is going on. They're gonna upgrade that puppy with cryogenic, because again, eventually you have to switch to cryogenic, because again, this great for low cost, but the moment your payload becomes bigger and larger, this is like, yeah, I can't do that. Again, ICBMs were designed to send tiny nukes, tiny miniature suns. They were not designed to send a space shuttle orbiters. So fundamentally, you have to switch to liquid sooner or later, but this can be a very good stopgap solution for A, getting your feet wet, and B, taking care of rapid delivery. So what about the mission? Vikram 1. Basically, the mission was named Aagaman. Aagaman is Sanskrit for entrance, so to say. So inaugural flight happened on 18 July 2026. Sachit Dhawan Space Center, basically it's almost our own Florida. It looks into the Bay of Bengal, so to say. Launch happened on 6:35 Universal Time Coordinate, or in Indian time, that was 12:05 p.m. Indian Standard Time. I saw it live. First try, all successful. Now his deal, lot of rockets have that. Lot of rockets, like Falcon Heavy has that. Basically Blue Origin, New Glenn has that. Lot of companies have that. However, the list, basically that's the first qualifier. One launch, one go. That's a lot of rockets achievement. One launch, one go with payload, paid payload. Yeah, the list shrinks. The list shrinks so much so far. At this point in time, only China has that. Like China has 4 private company. If I'm not mistaken, 2 or 3 of them managed to send paid payloads into orbit in one go. However, legally they cannot be certified as a mission. By law, in basically insurance law, they have to classify the first launch always as test system. But you can pay them like, hey, take money, launch this puppy. So this is a big event. Like A, India made a private company, great. B, figured out the paperwork, ultra great. Deal with governmental bureaucracy. Whoa, rocket is easy. You dealt with governmental bureaucracy in India. Damn, my hat off to you. So they did that, and there were 7 payloads. It's not just like one. There were like heavy puppies. So there were a lot of payloads into this, and we had even cultural events into it. Basically a diamond flower, and basically people who are very responsible for Indian space program, they were a needle art of that. And yes, that's actual diamond. So this happened, 7 payloads were there, and German D-Cubed was also a prime contractor. That's why I said like international money is starting to funnel in now. Now, one thing you have to understand, CubeSats are now an ecosystem on itself. Benefit of that is there are a lot of sub companies whose sole job is to provide auxiliary service for the CubeSat, meaning we're going to provide you the racks that allow to yeet CubeSat. We're going to build solar panels that are very slim, very easy to roll on and off for CubeSat. So there are a lot of companies, and again, that's the whole point of German DQ. There are companies who are making like tiny thrusters for tiny CubeSats. So CubeSat is a big ecosystem now. It's almost like a USB at this point in time. So people are building different support infrastructure. So you have a payload requirement and you need a CubeSat, cool. But what about rather than developing every aspect of it, you just pick up a phone. Hey, I need to deal with the radio antenna. The company is like, yeah, what is your CubeSat? Cube, 3 cube, 2 cube, 6 by 6 cube, basically 3 by 2 cube, whatever have you. They can provide you hardware for it. So those sort of ecosystem are very important. So, and technology demonstration was the core essence, as in they even have a grabber testing that was going on in space. The fact that they want to grab chunky things, big things, chunky things, they want to grab it and deorbit it. You do not want to basically kaboom it, because kabooming it is a Kessler syndrome. So you have to handle the big stuff before it becomes a hazard, so to say. So a lot of companies are testing that. And again, this is the core essence. If you can see the live stream, I have linked them down below. If you see the live stream, it was fast. Like it was fast. It was like it cleared the tower like there is no tomorrow. Like, bye. So it was fast. Like you can see how quickly it was rising in kilometers. It was like fast. And the camera was not able to track it. It's like, oh, yeah. So this was Vikram 1. First launch, first successful mission with paid customer. And it worked. So what can we expect in the future? Now, let that be very clear. I'm not that excited about the fact that the first launch happened, although I'm excited about India at this point in time. The reason is because this is an ignition sequence that, yes, A, Indian company can come here and make, private company can be made here. B, they can get funding. We have more than enough billionaires in India, more than enough, okay? But they do not want to invest in risky things. Most of the time, they will always have the same dialogue. It's like, hey, I can put money in real estate and multiply. It's like, yeah, might as well take money from foreign markets. It's surprisingly easy. So in coming years, this should be just looked at as like, the first event. It should not be like the event, first event. And space policy, Indian space policy was cauterized, as in like legalized in 2023, meaning you can now actually make a company that makes the whole rocket and launches it under its own name, rather than, okay, I make a rocket and I sell it to ISRO. No, I make the rocket, I sell a service. ISRO can buy it, some other private players can buy it, but it can be done in 2023. That's why I said like the legal paperwork is the big deal here. And in 2024, they allowed FDI, foreign direct investment. Basically, I did say we have more than enough money. It's just that nobody wants to put money in risky endeavors. So they're like, okay, foreign money has to come in, otherwise this will not work. So they allowed it. That's why German players are there. Like there are a lot of big names there who are putting money into this sort of Indian startup environment. And they will have many players. My hope is by 2030, when I'm making this sort of video again, there should be a lot of companies, like this should be boring at that point in time. So we have Agnikul Cosmos, these are there, Liquid Rocket, and the way things are going, they will be the second player to knock it off. And then you have Sputnik, they are also working, they're a bit far behind. So I think second would be this, Sputnik would be third, and then you will have EtherX, they are also trying their stuff. They even want to, like their whole philosophy is second stage reuse. So people are going all out. And there are many players for the payload section also. These three I'm just showing as people who are making rocket. Be mindful, there are many more companies, but these three was the easiest to find. But there are other companies also. And once Skyroot happened, that means money will start to flow. People's faith will rise. It's like, oh, in India, you can do that. So yeah, it took government a bit longer than I anticipated, but at least they did. And again, now I can hope in future that same way I can say right now in China, there are 4 companies that have launched payload into orbit. I can say the same thing, hopefully a bit late, but in 2030, I would say. Yeah, India also has multiple private companies that have launched like, at least 4 or 5 companies. So that's the most exciting part about it. Not the rocket itself, not the mission itself, but the fact that paperwork has been cleared. The path has been laid bare. Like this is the first opening salvo. That's the most hopeful aspect of it. So this was my presentation on this Skyroot's Vikram 1 launch. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you've enjoyed it, click the like button. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me excitement. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.